Welcome everyone to this Connected Workflows webinar. Thank you all very much for joining me. Today I'm going to look at structural workflows between Revit, Advanced Design, Advanced Steel and a few other bits and pieces in between. For those of you who don't know me, my name's Jonathan. I'm a Customer Success Manager with Graitec here in the UK. And I'm also Autodesk Expert Elite. So to quickly start with a very brief two-page PowerPoint, what we're going to look at today is how we can start to introduce connected BIM workflows, particularly within the structural discipline. So today we're going to heavily focus within the Revit environment, and we're going to connect a Revit model out to a Graitec product called Advanced Design for FEM steel analysis. We're then going to go back into Revit. We're going to do a bit of structure analysis within Revit, but we're going to use the 360 Autodesk Cloud solution. We're also then going to look at the steel connections within Revit, how to apply them, how to modify them, and then we're going to export all that data out into Autodesk Advanced Steel, and we're going to look at what information comes through from Revit, how we can apply and append the data within Advanced Steel, how we can add data, and then finally we take that all back to Revit. So what we're going to try to do is look at multiple platforms, multiple workflows. This is sort of the first webinar that I've done on this type of scenario. So what I will do at the end is I will open out the session for any questions that you may have. Feel free to put your hand up or comment in the chat panel, and then I will review it at the end. Also feel free to give me some suggestions on what you would like me to cover in my next webinar in terms of workflow. So this process today is more about showing the workflow rather than an individual demonstration in each software product. So I'm just going to jump straight into it. In my webinars I like to start from scratch. I'm going to start with a completely blank Revit file. So I'm just going to start my Revit and I'm going to click the default structural template. So I'm not going to hide anything that I do. I'm not going to have a predefined drawing. I'm just going to jump straight into it. And the first thing I'm going to do is go to the application menu, save as, and I'm going to create, I've got a folder already existing on my desktop, and I'm just going to save the project over an existing one I was testing previously. So that is my project saved. I'm going to click into level 1 and I'm going to start drafting a very simple structural grid, and I'm just going to keep it very simple just for this process, just to show the connected workflow. So I'm going to put in some grid in the X direction, and then I'm going to put some in the Y, and just as I'm doing that I'm going to switch that to alphabetical, and I'm going to put 5 meter spacings between them. So I'm just going to keep it very simple. I'm just going to tidy my grids up a little bit. So some of you who already know Revit know this is pretty simple stuff. So once I've got a grid structure in, I'm going to go straight to my elevation, and again I just like to tidy up everything so that it looks correct. I'm going to add a new level into my system, and I'm going to put that, let's say 1800 to there. So I've got the basis of what I want to create. So I've got some grids in and I've got a level structure. So go back to my level 1 view, straight to my structure tab, and I'll quickly go with an isolated foundation. I'm going to go with the standard size, click it all based upon grids, and place all my grids, and then I like to just take out what I don't need, so I add them all really quickly. Immediately create a 3D view, and you can see that again, nothing's preset, it's all pretty standard out of the box. So back to my level 1, and I'm going to add some structural columns. Again, I'm going to define the height, and I'm going to strain it to level 2, and again I'm going to place it at column or at grid intersections, and then confirm and do the same thing again. And if you can see there that I did actually forget to change the size, but I select all my columns and then just use the type properties to change it back to that. And I'm going to hide off my analytical model just for now. So you can see I've quickly put in some columns on each of the pad foundations. If we take a look at, and I just take note of the grid line C, go to my east elevation, and I want to put in the rafter, so I go to the beam, and I want to pick a work plane and put it on grid C, and then I go grid C, automatic. I'm not 3D snapping it, and I'm going to go with a standard rafter size, so I'm going to drag from there to there and from here to here. We have a look at 3D and you can see that I've got a rafter added to my building. Go on level 3 and I can easily select my rafters, and then I can do a multiple copy from here to here back to 3D, and you can see that I've now got the rafters in each one. Select the column attached to the top and just do that for each of the mid posts. I can go to the beam option, turn on 3D snapping, and then change it to a 127 for the tie beams, and just make sure that I am snapping to the right points. And again, put it up at the ridge to there. So a very simple, quickly generated Revit structure. So what we're going to look at now is that you can start to author your projects within the Revit model and use Revit as the host for all this content. So rather than going to an FEM package or even Advanced Steel, you can use Revit as the hub, because it seems to be the key driver in most of the projects, well, especially here in the UK. So just a quick save to my project. I'm going to go to my Analyze tab. So this is where we can start to particularly put in load cases. So I'm just going to delete some load cases out, because what I'm going to do is export the load cases from the Revit model to my FEM package. In this case, it's going to be Advanced Design. So if these are included, they will create a load case folder within the FEM package. I don't really want to do that, so I'm just going to go with a dead and alive and a snow load. And again, just hit save. So I've got everything correct. And when we're looking at workflows, what we're trying to do is stop the repetitive nature of creating content in each individual package. So when you subscribe with Graitec, you get a thing called the Graitec Power Pack. And what the Graitec Power Pack is, it's an extra set of tools for Revit, and in particular it's got this command called Advanced Design. So when I want to create a connected workflow with our own product, Advanced Design, I can simply just click the button, confirm a few options. Do I want to create a material? And what the system is now doing, it's exporting my Revit model out to Advanced Design, and it's an auto start, so it will start the new program. So just bear with me. You can see that the splash screen pops up saying that Advanced Design is going to start. It asks me whether because I've assigned certain materials within Revit, so you can see that this material, steel 43275, is not within the database, it's not recognized, and all I need to do is just assign the existing material, select it, and click assign, and it will assign that material as well, so it matches the Revit material to the Advanced Design material. And you can see what happens is that the structure comes across from each of the systems. Okay, so I'm not going to explain too much about Advanced Design thus far. I'm just going to go in. You can see that whatever you draw within your Revit model can come across into Advanced Design, so you can speed up the analysis and the design. So rather than go into Advanced Design, start again, do it all, you can see that the project comes in. And what I can do is I can add in content. So it's a similar modeling tool to what you get within Revit. You can choose your sections. I can do what I want, so I can say that that is going from there to there. So you can do all this type of thing. And again, similar to what is in Revit, that it goes from node point to node point. You can end up with a similar structure. So if you're looking at using, again, as I said, this is not sort of the modeling or the training webinar. I'm just going to quickly go in and apply some information. So first thing I want to apply would be a self-weight onto the complete structure. I then would want to look at the structure, just look at all the footings, and I tend to change these from a fixed footing to, so it's pinned, so that changes the load criteria. What I would want to do then is go to my live loads and I'm just going to select my rafters. I'm not going to do a complete process. I'm just going to load these on selection, and I'm going to put a -2 load on there, and I'm just going to deselect and then loads auto till. So you can see that I've loaded up the rafters. I can apply some combinations, so go to properties, simplified, generate, click yes. That's applied some simple load combinations. And what I can quickly do is go into the analysis side of it, run off an FE analysis on steel design, and advanced design will go off and it will look at the analysis, look at the block clean and the shear. And again, I'm not spending too much time in the system, but you can see that you can go in, you can do your analysis, have a look and see what has worked, what hasn't worked, and do all that. So by connecting the Revit workflow, it dramatically speeds up what you may have to do within an FEM package. So I'm just going to click File, I'm just going to save that, so I've got a version of that project saved within my folder. Now what you can do is you can use the BIM button and you can fire that back to Revit if you want. So you can take the advanced design model and take the loads back to Revit, and then you can go on and it will affect all the changes. But sort of this is sort of just giving you a flavor of what you can do. So another feature within Revit is the structure analysis. So this is a structural analysis toolkit which you can easily add to Revit. It's a free add-on through the App Store or through your Autodesk account. And a really neat feature is if you've got a Revit model, so we've engineered it out in the FEM package, we can take that back in, but I'm just going to show you this neat little feature where we've got this thing called Analyze in the Cloud. So I'm going to click Analyze in the Cloud. And what it will do is it will run through a series of steps. You can see it's checking my entitlements, which is linking it to my Autodesk account. It's extracting the model, it's verifying the model, it's uploading the model, and it's going to configure a new analysis. What it will do a static analysis in the cloud of the structure. So sometimes you don't even need to go to an FEM package. Revit has the ability to do it in the cloud for you. So currently it's whirling away and it's uploading it into the cloud. And once it starts to upload, I'll then configure on to the next step and let it do a lot of background work. So you can see here that I'm going to do a static or a gravity analysis. I can change the analysis profile and I can give it so I can do something like that. I can add self-weight and you can give the report titles, and I just click start. You can see that comes up the little flyout that analysis has been started. So I can click that and you can see you get the structure analysis dashboard, and you can see that it's now uploading. If I open the dashboard, it will fly out to my web browser and it will show you, it will automatically sign me into a structure analysis 360 account. And there I have my analysis uploaded into the cloud. So whilst that's running in the background, I'm going to go back into my Revit model, and you can leave that there. You can minimize it down. It will continue to work in the background. So another thing about Revit, and now with it enhancing year by year, and coming in 2017, was the ability to add structural connections. And enhanced in the 2018 release is, I think, 122 connections. And these connections come from advanced steel. So when we look at the advanced steel package, we have a series of connections that come as default, and you can see the little images. And if we go back to our Revit platform, if we click the little connection settings, so this loads in and allows you to configure and load what connections you may want to use within your project. So just give it a second or two to open up the structural connections, and you can see that the little images look very, very similar. In fact, they're identical to the ones that are used within advanced steel. So what you can do here is you can add what connections you're going to use within your structure. So I've got a base plate. I'm going to put a haunch plate in. I'm going to go with a gable wall end plate. I've got an apex haunch, and I'll probably go with let's go with a single-sided end plate and a double-sided. So you can load all of them in. You can see that there's quite a few, but I'm just going to load what I need and select OK. So part of this is connecting the workflow to the structural fabrication, and again, taking your Revit model, into structural intent drawings where an engineer would show complete connection detailing. So it's really quite simple to use. You select your structural element, go to the structure tab, click connection, and that will go in and apply a structural connection node. It's got a generic connection, and then you just specify which connection that you need. Select the pull down, and you can see that it will work upon, even though you've got lots of connections loaded, it knows that because you've just selected a column, the most common joint that you will wish to use in this case will be a base plate. So that will simply add a base plate to your model. You may need to change it to fine detail. And you can see there you get your connection. On default it may not be correct, but once you select it you can see that it brings it in as sort of a group of objects. You can click modify parameters, and this will allow you to change it. So I'm just going to go with a 20mm base plate. You see as you change it, the model is getting updated and changing. And within this, because I know this connection quite well because it comes from Advanced Steel, there's over 218 different parameters that you could possibly change to affect the type of base plate. But this is more about showing you how to apply it. So I'm just going to select the connection. I can do a copy multiple, and I can just select. You can do this within any view, and you can see that because I'm not being too accurate, I don't need to be, because I can just select a point close to the base of the column and Revit will automatically snap it and sync it into position. So very quickly I can go in and just produce a base plate. We look at a connection which is a little bit more detailed, so I'll select the column and the rafter. Process is the same, structure tab, select the connection, and now you get something a little bit different where you've got a circle here and a number 2. And what this is, this allows you to determine in simple terms the bearing member. So what is the supporting member? So if I want this to be the supporting member, in this case my column is correct, select my pull down and I've got the haunch connection. See, that's not quite what I want, so I'm going to click modify parameters. Dialog box pops up again, and just we go in and have a look and see the way it's dynamic outside of the. So I want to go to the cap plate. I want a horizontal cap plate, and you see the model will update, and I want to increase that by 50mm. And we close the dialog box down. You can create multiples. If we select this, I can go in, structure, connection, apply my apex haunch. So it can get quite quick as you get more and more used to the system. Again, modify the parameters of that. Stiffeners, and I'm going to change that to none and none. We have a look at the bolts are a bit tight for me, so I'm just going to go in and change it. I'm going to say that that probably should be 150, just move it down a little bit in my system. And we look at this where we've got a gable post. So again, beam to beam, go to structure, connection, and we look at what we need, and I've got this gable wall end plate, and you will notice that something strange happens a little bit, and this is because of the bearing member and what is the supporting member and what is the prioritized member. So in this case you can see that it's cut it off in line with the gable, so I simply just stretch that up to there, and you can see the way it goes green. I change it and see the priority for the connection then updates, and again beam 1, rafter 2, structure, connection, determine the type of connection, single-sided end plate, not quite right, should go to that one, and you can see that it will simply update and change. Now what you can do, and what we're finding with a lot of our customers, is that they're providing a full Revit model with as much connections as possible. I'll simply just put in a single-sided end plate on this just to show you. So connection, single-sided end plate, you can see that I'm after getting a little notification to say that my structural analysis is complete. And if we go to our analysis tab, we can open the dashboard again, and it will, I probably didn't need it, I just needed to go to my web page, but you can see that we've got our analysis, and we can go in here and we can look at the report. So this will have done a very quick static analysis. So it's given the parameters, the load cases. We've got a general view of the model. We've got the analytical model with the load cases that are applied, what reactions we have. And again, you've got the sum of all the reactions, the global system, the extremities, the nodal supports on the building, any displacements, maximum displacements, the forces in the members. You can see this is all done very, very quickly within the cloud. So a really nice and neat feature that should be explored a little bit more. So I'm just bringing it to your attention that we do have this, and you can see that's all worked in the background while I was continuing to work on my Revit file. And you can see that I've added in a connection. So I'm just going to repeat this just before we send this to Advanced Steel. So I'm going to put a haunch connection in just there. I'm going to modify its parameters. And we're going to go with a horizontal cap plate and 50 millimeters. And then we choose this and this, so we can close this down. Let's add a single-sided end plate. So you can start to see very, very quickly we could create a really good structural intent model. So I'm just going to save it. And part of the workflow can also be, so instead of going to the FEM model, we can send this to Advanced Steel. So if we want to take this on to a fabricated model where we're producing part assembly and GA drawings, we can use the free Autodesk add-in. We've got the Advanced Steel extension. We can look at the settings. This can look at what we're exporting, what we're importing. And the big thing to look at is that I would ensure that the export beam shortenings is off, because we've modified the connections and the length of the rafters and the columns. And if this is ticked on, it will export them shortenings to Advanced Steel. So we're going to leave that on. We're going to say they're all dynamic, and then we go to export, and this will create, some of you are probably quite familiar with an SMLX file. So we're going to go with the Revit out, save it, we're going to replace what we've got, and the system will create a transfer file that works between Revit and Advanced Steel. So we're going to create an SMLX file, which is a steel markup language. And then if we look at, let's go straight to Advanced Steel. So this is Advanced Steel for people that are not familiar. So this is the Autodesk structural detailing package. And what we can do is we can go to the, well, first of all, I'll just save it as a drawing. This is built on DWG technology. So we go to desktop, and I'm just going to resave my AS model into a blank file. And I'm going to go straight to export and import. And I'm going to look at, you can see that it's got a Revit tab and a ribbon. So I'm going to import my file, and you can see that it's timestamped the 9th of the 6th, 2017, 15:23, which is 1 minute ago. And I'm going to click open. So again, connecting the workflow. This means that instead of me redrawing the process within Advanced Steel, you can see that very, very quickly I have got what I've drawn in Revit has very, very quickly been transcribed into Advanced Steel. So if you've got people giving you Revit models, get them to add the connection, because you can see, guess what? The connection comes through exactly as it should do from Revit. But the even better thing is, if we select it, we right click. For those of you familiar with Advanced Steel, it comes through as a joint. So when we select it, we right click, you can see that I've got the same connection that I have in Revit here. So I can select it, modify parameters. Same connection also exists here. So we can go in, we can modify it, we can change it, we can go to bolts, bolt groups. We can say there's 3 in the second group, but they're only 75 mil. I will get it right. So something like that. So you can see these are all standard connections which come through. So we can look at the apex, right click, advanced joint properties. And again, I can add back in the stiffeners which were removed, and you can see that they're coming in both sides. And because these are standard connections, we just go straight to our advanced steel tools where we can start to modify, and I can start to just duplicate what's happening throughout my model. So even if the guy in Revit gives you a file with one connection, it's still way quicker to do that. And what you can do is, we all know, if you're familiar with advanced, we can go in and configure all the connections. So I'm just going to copy some connections about the system. You can see that sometimes, depending on what we have copied it won't always work. So sometimes it may be better just to put that connection in. But you can see the process is very simple. Single-sided end plate, and if I want to add my own, I can just simply go into the system and just use advanced steel as you normally would. So add in a single-sided there, or double-sided with end plate here, and just do something similar here. So you can see that we're now starting to connect the Revit out to an FEM analysis. We can also upload it to the cloud, and we can also start to affect changes, and it can definitely speed up the advanced steel design process because we don't need to redraw anything. Everything is set out from my Revit file. I'm just going to quickly save that. For advanced steel, what we do find is if you're sending it back to Revit with the reflected changes, I do find that sometimes we work better and map the sections better if everything is pre-numbered. It's then a simple case of doing the export. So we go to AS out, so we'd save that out, and that's going to export, and it will always sort of warn you to make sure that the model that you've just exported is the exact same as the model in case you want to reflect and synchronize changes. So that has created this. I then can go back into Revit, and this is where we start to have options. So because I've exported this out to advanced steel and I've made some changes and some additions, we just need to look at, if we're going to import, what do we want? So do we want to import the plate? So if we've designed a plate in advanced steel, we want that to come through. We want to import only structural elements. So if you've got non-structural, we would tick this off, but I'm going to leave that pretty much as standard. And then this time, instead of importing, I'm going to go synchronization. I'm just going to let Revit whir away. So this is where I can synchronize between the software. So I'm going to load my file. You notice that it is timestamped 1527, so 1 minute ago. And this looks through the synchronization file. So what we exported, it's then checking to what we changed. And you can see that there's quite a lot of things that have updated. So some of the columns, some of the beams have changed, and this is where we've added joints. You can see that some of the connections remain the same, but I'm just going to select everything and I'm going to apply all the actions. So I'm just going to do a complete dump, but you can choose one by one what you want to synchronize, what you want to change. And you can see that Revit will take a little bit of time just to start reflecting and detailing these changes. So where I've added a new haunch, Revit will also then start to detail this information. Then click close, go back into Revit, and you can see that sometimes, depending on what way it's imported, Revit doesn't always update the graphics, but what I tend to do is just select all the instances visible in the project, right click, and I quickly go in and I start to play about with my visibility graphics. I tend to turn them solid, go to a surface transparency. So to do that, select this, visible in the view, override the graphics. So I like to go with blue for the rafters, go with solid, again, do a transparency. And then what I also like to do is I like to do the connections as well. And surface, and I like to go with orange for my connections. Go with solid, and I do like to put a 40% transparency on them. You can see there what you've got now is all the changes that we've added in advanced steel are now visible back in Revit, because I've done quite a lot with the the visual style, I'm just going to create a template. So just from Advanced Steel, and I've now got that as a view template. So if I ever create a different model, you can now start to see that any changes we make within Advanced can quickly go either way. So if we add connections in Revit, I can sync them out, sync them in, and the process remains the same. So that sort of concludes a very quick whirlwind run through within 31 minutes of how we can start to use Revit as the central hub for using all this data and sending it in and out of various packages. And you can see there's lots of add-ons, lots of different things. So now what I'm going to do is open this out to anyone that has any questions for me. If you want to just put them in the chat, if you've got anything that you want to ask, just shout out and let me know. If anyone wants to be unmuted to ask me something, just stick your hand up, and if anyone has any questions, just shout out to me that you would like me to cover next time, you would like me to look at, explain now between the systems, what I've covered you. Just don't be afraid to ask me anything. So I've got a first question on the file size. By adding the connections, not in my view. I don't think it adds a huge amount to it. But obviously the bigger the Revit file, and if you put, say, 500 connections in, obviously it will have a little bit of effect. But in the workings that I've had with it, I've not seen any detrimental effect to the file size. I've not seen anything that has slowed it down or made it non-manageable. Again, it all depends on if you're going to use Revit as a structural and detailing package. Obviously there is limitations as to what you can do in terms of how quickly you can add multiple connections and grouping connections together and having the same connection update with master joints and stuff like that. That's more better in Advanced Steel. And in Revit, it's still sort of individual elements. Is it possible to have the same workflow with Tekla? It obviously is not as streamlined because this is all sort of working upon Autodesk technology. So obviously the link with Revit to Advanced Steel is bi-directional, sequential. The link out with Advanced Design is pretty good. Obviously we're an Autodesk developer on top. You will need to check. I don't have much experience with Tekla, but I do know that they can export through IFC to Revit, but I'm not sure they will have the connection interoperability that you've just seen. So I'm just going to answer each one. Will Advanced Concrete work similar to Advanced Steel? Advanced Concrete, as far as I know, is discontinued by Autodesk. I'm pretty sure that it probably will work in terms of the SMLX file will transfer. I'm not sure on the connections. I would probably need to test and check with some of the Graitec gurus here who've dealt with concrete. I've personally not not seen advanced concrete working. I do know lots of the concrete functionalities now within Revit, so it may be the case of if you're doing reinforcement, look at what Revit can offer in terms of the reinforcement side of things. So I do know that within the structure tab we've got the reinforcement area, and Graitec also have a product called the RC BIM Designer, which is looking to automate placement and the drawing generation within reinforcement. So I think possibly look at the Revit solution for reinforcement for concrete elements. Yes, Graitec's products do support American codes and standards along with Canadian and most of Europe. Yes. So the Advanced Design product does cover America. There is a product called Advanced Design America, which is obviously comes with all the AASC stuff and all the American codes. So yes. So can we use American codes and British steel sizes? Oh, that is an interesting one. I am not. I know we can have both in the system, but I do know you need to toggle between AISC and BS. I will have to check that when you I'm not sure. I'm going to have to check whether we can actually utilize a British steel size and then apply it with an American code. My hunch would be no, but I will have to check. So I will come back to you, Robert, on that. I've got your email, so I will drop you an email once I find out whether you can or you can't combine the two. So has anyone got any other questions before I finish up? Okay, so I'm going to just finish it up now. If anyone would like to drop me an email, my email is jonathan.hand@graitec.co.uk. You can also just search for me on LinkedIn, just reach out to me. Go onto the Graitec website, just contact us if you've got any questions. I would be extremely grateful if you want to suggest something that you would like for me to explore and show you in my next session. I can put on a webinar in the next couple of weeks. I do like for people to suggest some ideas of workflows and what more they would like me to show and explore, because this again was pretty much just a whirlwind introduction into what is possible and where Autodesk and Graitec are going with their technology advances. So thank you very much. I'm going to end this web session now, and I hope to see you all again soon. Thank you.